Another restless night in the life of a teacher. I need to make breakfast before I go to school, but I have no bread in the kitchen. What shall I do? I know I will go to my favorite doubles vendor and purchase some doubles this morning for breakfast. So students, the topic for today would be linear inequalities and optimization, and we would be writing inequalities to represent real-world constraints, represent inequalities on the Cartesian plane, identify the feasible region, and find optimum values using an objective function. I see my favorite doubles lady is hard at work this morning, but what shall I buy? I need to buy at least 2 doubles because a true Trini cannot only eat 1 doubles. I also need to buy at least 1 juice because I like a lot of pepper in my doubles. I have $40 to buy my breakfast and each item costs $5. I am on a diet as well and each doubles has 250 calories and each juice has 100. How can I solve this problem? So for today's lesson, we are going to use 2 different manipulatives that we can get online. And these are the links for them. It is a virtual whiteboard and a geoboard we will be using for our lesson. Okay students, now that I have my 2 digital math manipulatives open, we can now start to solve our optimization problem. The first step would be to define our variables x and y. So we can say let x represent the number of doubles, and we can say let y represent the number of juices. So we are going to have 3 different inequalities for this question. So I'm going to section my whiteboard into 3 sections. Now as I was by the doubles lady, remember I said that a real Trini cannot only eat 1 doubles. So how can I represent this problem as an inequality? X must be greater than or equal to 2. I also said that I at least need 1 juice to quench my thirst. So y must be greater than or equal to 1. Now the doubles lady told me that each one of these items cost $5 and I only have $40 in my pocket to pay for this breakfast. So how can I have a hearty breakfast? I need to write one last inequality to represent the total cost. So I can write the last inequality as 5x plus 5y is less than or equal to 40. I can simplify this by dividing throughout by 5 and get x plus y is less than or equal to 8. So there we have it. We have our 3 inequalities and now we can start to represent these inequalities on the Cartesian plane using my digital geoboard. Okay students, now that we have our virtual geoboard open, we can now start to represent our inequalities on our Cartesian plane. We can change our settings to rectangular, gridded lines, and number our axes. Our first inequality is x greater than or equal to 2, so we need to draw the line x is equal to 2 and shade the region to the right of this line because all coordinates to the right of this line would have an x value greater than or equal to 2. So we are going to use yellow and shade to the right of this line. Our second inequality is y greater than or equal to 1. So we need to draw the line y is equal to 1 by stretching our rubber band from 0, 1 horizontally across. Now to represent this region, we are going to shade above this red line because in this region, all coordinates would have a y value greater than or equal to 1. Our final inequality is x plus y less than or equal to 8. So we need to draw the line segment x plus y is equal to 8. But we need two coordinates to do that. So I'm going to substitute x is equal to 0 and I would obtain y is equal to 8. And I'm going to substitute y is equal to 0 and obtain x is equal to 8. So I have two coordinates 0, 8 and 8, 0 to draw my line segment. So I go back to my virtual geoboard. I'm going to use a green rubber band this time and place it on the 2 points Now I need to test a point on one of the sides of this line. So I'm going to test the point 0, 6 on my inequality. So I'm going to substitute 0, 6. So 0 plus 6 is less than or equal to 8, which is true. So we need to shade the region that contains this point with respect to the line segment. So I'm going back to my geoboard, deleting the point. I'm going to choose my green marker and I'm going to shade this region. Now the feasible region would contain all the colors, and as you can see, the right angle triangle here contains red, yellow and green shading. So we have our feasible region, and we can represent our feasible region using a different colored rubber band. So I'm going to use purple and stretch it across my feasible region. So far in our lesson, we have carried out the first 3 steps to solve our problem. We formed our inequalities, represented them on the Cartesian plane, and found our feasible region. Now all we have to do is substitute the critical points into our objective function to find the minimum number of calories I have for breakfast. So students, now that I have my feasible region, I can also identify my critical points, and I can substitute these critical points into my objective function. But what is the objective of this question? I want to find the minimum number of calories that I can consume for breakfast. Now before we said that each doubles we consume contains 250 calories and each juice contains 100. So if I let the total number of calories be z, I can write my objective function as 250x plus 100y. Where x represents the number of doubles and y represents the number of juices. But what are our critical points? Our critical points are the vertices of my feasible region, 2, 1, 2, 6, and 7, 1. I need to substitute each of these points into my objective function. So as I substitute each of these points, I would get the total number of calories for each option. Now we want to optimize the number of calories that we intake for breakfast, meaning that we want to minimize the number of calories. So the minimum value for the number of calories would be our first option, which would be 600 calories. So if I want to minimize the number of calories that I intake for breakfast, I need to consume 2 doubles and 1 juice. And as we complete this question, I want to leave you all with an image of this sumptuous breakfast. Linear programming can be used to solve a lot of everyday problems, especially in transportation and logistics. A company needs to deliver goods from multiple warehouses to various stores at a lower cost. An objective function can be used to minimize transportation costs using constraints such as vehicle capacity, demand at each location, and fuel limits. PriceSmart and Massey can utilize this function. A hospital can minimize total wage cost by using constraints such as staff availability, legal working hour limits, and shift demand. Airlines use optimization models to decide how many seats to sell at each fare class, when to raise or lower prices based on demand forecasts, and how to allocate limited seats across different customer types. After a delicious breakfast, I need to burn off some calories at the gym. I need to do a maximum of 6 sets of squats and a minimum of 3 sets of jumping jacks. Each set of squats takes 3 minutes and each set of jumping jacks takes 2. I also only have 30 minutes to do this workout before I need to head to work, and I want to maximize the number of calories burned. Each set of jumping jacks burns 30 and each set of squats burns 50 calories. Can you all help me with this optimization problem? If you all came up with these inequalities for my workout routine, you are absolutely right. Can you all represent these inequalities on a Cartesian plane for homework? So to close off class today, I would like to recap some of the steps we used to solve these questions. We formulated the inequalities for the problem, represented these inequalities on a Cartesian plane, shaded the feasible region, and identified critical points and substituted these points into the objective function. I hope everyone had fun in class today, and I will see you all on the next time. Goodbye.